Welcome to ControlNeXT, the official breakthrough in controllable generation. Whether you're creating images or videos, ControlNeXT is engineered for unmatched efficiency and precision. With our cutting-edge method, we reduce trainable parameters by up to 90%. Compared to ControlNet, that means faster results, quicker convergence, and smoother workflows. Need to tweak styles? No problem. ControlNeXT easily integrates with LoRa techniques, giving you flexible control and stable outputs every time. Check out these real-time demos showcasing the incredible power of ControlNeXT in action.
I just killed a man, she's my alibi.
So before starting with the installation, so this is the original repository for ControlNeXT, which have a lot of features available. You can go through different folders and see how it works. There are examples provided here. However, for video to video, we have this ControlNeXT SVD V2 available. So what I have done is, since there are several changes required in the code to make it work on low VRAM system, I have created a new repository which contains only SVD V2 folder. So we'll follow the guide. I have added the guide in the GitHub page only. You can navigate to the inference section and start following these steps. So we'll start by cloning the repository. So navigate to the folder where you want to install, type cmd in the address bar and press enter. This will open the command prompt and we'll start by cloning the repository. Next, we'll navigate inside the clone repository. Now this works fine on Python version 3.10. So you can check your Python version using Python -- version. So if you have 3.10 installed, it should work on higher versions also, but you have lower version, you can either upgrade it to Python 3.10 or otherwise you can use Conda to create the virtual environment. I will use Python to create the virtual environment. For that, use the command mentioned in step 3. Now, once the environment is created, we will activate it using venv script activate. Now, I have learned that this package, wheel package, actually speeds the installation. So some of the libraries that we install, sometimes they need to be built. However, if we install wheel package before installing the requirement, so some of the packages will be downloaded as a wheel and the installation will speed up. So we will install the wheel package. Now, once this is installed, we will install the requirements. So I made some changes in the requirements so that torch is installed with quota drivers. So copy paste the command mentioned in step 6 and press enter. Now, while the installation is in progress, let's download the weights. So for that, first create a folder called pre-trained. Then navigate inside the directory, create another folder called dwpos. Now, the models have to be downloaded in this manner. So this is how it should look like. So open this first link and download these two files, controlnet.bin and unet.bin in pre-trained folder. After that, download these two files in the dwpos folder. So after downloading, it should look like this. Inside dwpos folder, we should have these two files, and in pre-trained folder, we should have unet.bin and controlnet.bin. Next, we have to clone the SVD models. So make sure you go to Hugging Face and accept the terms of this. And if asked, you need to provide the token for logging into the Hugging Face repository. Once you have done that, copy this, then navigate inside the directory, open a new command prompt, and paste this command. Now I have removed examples from this cloned repository, the repository that I have cloned. So if you want to download the existing examples, if you want to try with existing examples, go to the original repository and navigate to this folder, and you can download examples from here, and you can download them in the root folder. And then you can maybe try with examples first and then try creating with your own images and videos. Now, once the installation is complete, you can close the command prompt window. So each time you want to launch this tool, type CMD in the address bar, press enter. After that, activate the virtual environment. Now the original repository does not comes with any web UI. You have to use command line options to run this tool. I have, however, created the Gradio based web UI, including all the customizable options. And to launch that, use Python space app.py. So once it is running on local URL, you can control click on this link to launch the web UI. So this is the this is the interface that I've created. So here you have to provide the reference image. Here you have to provide the video file. Now this is the output directory. So all the outputs will be stored in outputs folder. Now there are some advanced settings customizable. So once you drop the video here, this maximum frame number will be generated automatically. You can reduce it to a smaller number if you want to just try. Here you have to provide the guidance scale. Here the number of frames that have to be processed in each batch. So I will just explain how you can use this for your advantage on low VRAM system. This is the stride, overlap, and then width height. So if you have low VRAM system, what you can do is if you are getting CUDA out of memory error, there are three options which will help. So this is the batch frame. You can reduce it to any number, and basically the fewer frames will be processed at a time. Then you can also customize the width height. So I have put width as 512 and height as 768. You can also try with, if you have good VRAM system, you can also try with 576 by 1024. And if you get CUDA out of memory error, then you can further reduce the batch frames. Here you will see the command line output, the processing that is happening. Then these are the model paths. These are some hard-coded values. You cannot change them. So this is the path where these models are stored. So this is the interface. Let's try one example. So I'm going to try with one of the examples that come with this repository. Here you will find the reference images. So let's use one of the reference image. Then in the video, you will find two video files that you can use. Now you will see the frame numbers are automatically populated. So I will only process 15 frames just for testing purpose and see everything is working fine. I will keep batch frames as 20. If you have high VRAM, you can even increase that like 30, 40. The default values were 40, but for low VRAM systems, I have kept it 20. And I'm going to use 576 1024. Everything else I will leave as default and click on Run Inference. Now let's see if it is using VRAM for processing. So as we can see, the processing is started. We have enough VRAM available. So that means I can increase the batch size by a little. Let's wait for the process to complete. Now, once the processing is complete, you will see this message that video is ready in this specific folder. So you can go to the outputs folder and you will see two output files. One is the standalone output file and second is with DW So once you convert the full video, you will not see that jerk in the very beginning and it will work fine. Now you may face some issues with the output file in terms of the phase. So for that, they have suggested to use phase fusion. So in the original repository, you will see how to install it and how to use it to correct the phase if you are facing the issues with basically phase. So you can follow the steps mentioned here and install phase fusion as a separate tool, and then you can pass the output file and process it through phase fusion. Thank you.